What is the electric field? The electric field. If we have a positive charge, means Q is some positive charge, say 50 Coulomb positive. Now electric field is seen around the positive charge, right? It is a space around which the electrical effect is felt. What do you mean by electrical effect is felt? If we keep some charge, say 1 Coulomb of charge, this is plus 50, this is 1 Coulomb of charge at certain distance r. What will happen? It experiences a force. Naturally it experiences force. Positive repel. This is force experienced by unit positive charge. This is an isolated charge. An imaginary charge plus. You don't get plus 1. Therefore, the force experienced by unit positive charge is also called electric field. See, at the distance, say, so much distance, the electric field is equal to, say, 100 Newton. 100 Newton per Coulomb, say. But when you take it somewhere here, distance will be more, is it not? The force will be less. The force experienced by a unit positive charge. This is at this point A. At this point A, the force is 100 Newton per year. At the point B, the force will be less, maybe 25 Newton per Coulomb. As you go away from the positive charge, what will happen? Right? Now, suppose what about this? I write like this. What is this? Here, what is the cause of the field? The cause of the field is what? Charge. This is called some point charge. Here, electric field is uniform. Uniform electric field is denoted by lines like this. Where is the origin? Origin of the field is not known. Here, origin of the field is charge. Here, origin of the field is. Suppose I write electric field is equal to 7 Newton per Coulomb. What does it mean? It means that if we keep your unit positive charge here, 1 Coulomb, it will experience the force of 7 Newton. If I keep another 1 Coulomb of charge, this also experiences 7 Newton. I'll keep another 1 Coulomb. It experiences 7 Newton. Therefore, I'll write Q0 is equal to 3 Coulomb. This I call test charge. Test charge. What is electric field? Uniform electric field is a vector quantity. See here also uniform field. Why? At this point 7 Newton per Coulomb. At this point also 7 Newton per Coulomb. Here also 7 Newton per. Every point it is 7 Newton per Coulomb. Both magnitude and direction it is same everywhere. It is called uniform electric field. Now, what is the total charge, total force here? Total force is equal to 21 Newton. That means total force is equal to 21 means 3 into 7 Newton. 3 is what? Test charge is not Q0. This is a force. This is 7 Newton. Force per unit charge is equal to 7 Newton per Coulomb. This is called E. Therefore, electric intensity or field strength, all one and the same, or electric field or electric field strength or field strength or electric field, one and the same. It is denoted by this. This is what? Force per unit charge. Right? Force per unit test charge. This is what? Force per unit charge. Right? Then what is the force? Suppose here I write, this is the uniform electric field E. Here I am keeping some charge, test charge. What is the force? Force is equal to cross multiply. Force is equal to Q0 into E. Correct? Therefore, this type of questions they will ask you in CET and all that. Now, this is force uniform electric field. But what is electric field due to a point charge? It is entirely different. Suppose the point charge is there. This is the point charge plus Q. Here force is maximum because closer. If you go away, force gradually decreases. Understood? Here force is common. Wherever you go, force is same. Uniform field. Wherever the distance, wherever you move, force is same. That means 7 Newton per Coulomb. 7 Newton per Coulomb. Electric field with respect to all distance it remains same. But what about here? As you move away, what happens here? More force, here less force. Suppose I keep a unit charge. That means some test charge here. Test charge at a distance of r. This is also positive, this is also positive. It experiences a force. According to Coulomb's law, force is equal to what? 1 by 4 pi epsilon naught q1 and q2 by r square. Right? Therefore, force per unit charge. This is what force per unit charge is equal to 1 by 4 pi epsilon naught q by r square. This force per unit charge is nothing but electric intensity. This is called electric field is equal to 1 by 4 pi epsilon naught q by r square. So what is the title we can give? Electric field due to a point charge. Right? How it varies? This is that. Now what? Consider for 2 marks they'll ask you. You have to make a center. Consider a point charge. Point charge plus q is at A producing an electric field. Electric field all around it. Your own sentence. Let P be a point. Let P be a point at a distance of r from the charge. Then force F is given by equation 1. You write Coulomb's law, you write it. You write by definition, force per unit charge is equal to electric field. That is equal to E, right? Is equal to F by Q naught. That is equation 2, right? That is right, Newton per Coulomb. If I write this much, you'll get 2 or 3 marks. 2 marks only they'll ask you. Okay, right? Therefore, electric field. What is the variation? See here. Electric field at the point with respect to distance. Here if it is very closer, R is very closer, right? Therefore force is maximum. Don't make it 0. If R is equal to 0, it becomes infinity. Therefore should not touch. It will be coming here. As the distance increases, what happens? As the distance increases, force decreases. This electric field at that point inversely proportional to square of the distance. This is called variation of electric field or field intensity with respect to distance due to point charge. They may ask you for 1 mark. What is uniform field? Variation of this what? This represent uniform field. Next, in a uniform field, if you keep some charge, if E is the electric field uniform, what is the force experienced by this? Force is equal to Q E. because force per unit charge is equal to E. You need not write Q naught. These 3 points are very, very important. Okay. Suppose if it is an electron, the force will be in this direction. Force is equal to EF, the opposite direction. For proton, it will be in the direction. Force is equal to mass into acceleration EF. That and all we can do it for the problem. Thank you.